The title for today's presentation is Cherry, which is a sound localization platform for people who are deaf and hard of hearing. Before we move ahead, I would like to give you a little bit more information about the topic. So what is sound localization and what problem are we trying to solve? Sound localization refers to a listener's ability to identify the location or origin of a detected sound in terms of direction and the distance. It is a very important ability as sound localization alerts us about everything that's going on around us. This ability of sound localization comes naturally to hearing people and is taken for granted. But for people who are deaf and hard of hearing, this does not come naturally to them. So they face the problem of sound localization on a daily basis. So if someone is trying to call you and you're a person who's deaf or hard of hearing, it is difficult for them to understand where the sound is coming from. And this is the problem that we're trying to solve today. So let's move on to the next slide, which is project outline. Let's see what we have in store for us today. So we're going to start with personal introduction. I'm going to introduce myself and tell you a little bit more about myself. Then we're going to go for the problem background, where we're going to talk about why is sound localization a problem for people who are deaf and hard of hearing. After that, we'll move ahead to project description. In project description, we'll talk about my mentor, Professor Gary, the objective, what we're trying to get out from Cherry, from our project, from our presentation, from our project, from my capstone. We're going to move ahead with the timeline, and we're going to talk about the actions taken in order to get the work done. We're also going to talk about results. What is that we got out of the study that we conducted, and later we're going to talk about the next steps, what's in store for me, what I plan to do, what are the lessons learned through my capstone. We're going to go ahead with thanks and acknowledgement to all the important people that made this happen for me, and we're going to go through a list of references if you'll want to. So let's move forward. Let's move ahead with the personal introduction. So that's me over there. My name is Rishikesh Karale. I'm from India. I came here to Rochester in 2014, and I started my master's in professional studies in the year 2015 with concentrations in human-computer interaction and design. So that's me. Let's talk a bit more about my background and what I did at art. So I completed my bachelor's in computer engineering in 2012 through Vidyalanka Institute of Technology in Mumbai. After that, I came here to Rochester for my graduate studies, and I ended up in MS in Professional Studies in 2015. Throughout the years, I've been associated with different labs where I've worked or did my projects at. So CAT Lab, where I'm currently working on my capstone. FET Lab, I was associated with FET Lab through my one of my courses, and we did a lot of UX UI stuff over there. We built devices, we analyzed them. Enable Lab was another lab that I was associated with. So what we did there was I was responsible for creating 3D models for prosthetics, and I was also responsible for writing a Python script for grabbing search results from websites, from Google search, and pinning it on the map. Through the years, for my capstone project, this year I won the first place at Effective Access Technology Conference. We won the first prize for our poster presentation. I was really surprised, and I couldn't believe when one of my coworkers told me about it. I presented a paper at the 7th Annual American Statistical Association Conference in Buffalo, and participated in NTID Student Research Fair and Imagine RIT. Let's move to the problem background and let's talk about the problem at hand today. Let's talk about why and how sound localization is a problem for people who are deaf and hard of hearing. Let's talk about why, even with the existing technology, sound localization is still not achieved for people who are deaf and hard of hearing. According to the statistics from National Institute of Health, 37.5 million American adults, yes, 37.5 million, which is 15% of the American adult population, is reported to have some trouble hearing. 37.5 million is a large number. It's a huge number. So you'd say, hey, aren't hearing aids supposed to be the solution? Aren't hearing aids supposed to help people who have hearing problems? In a way, yes, but let's talk a little bit more, and then I'll get back to this point of aren't hearing aids a solution. So let's talk more about the problem. Let's talk more about what's going on in the real world right now. Even though you have a vast variety of hearing aid technologies that exist in the world today, both analog and digital, we've seen that 80% of people who can benefit from using hearing aids don't use them. This is another statistics that we got from the National Institute of Health, which says that 4/5 of the people, so 4/5 of 37.5 million American adults, which is roughly 30 million people, these people can benefit from using hearing aids according to the studies, but they're not using hearing aids. So even if hearing aid is a solution, if people don't use them, that's still a problem. So when we consider 80% don't use hearing aids, it just screams out that hearing aid is not the ultimate solution for our problem. Hearing aids is not what people want. Let's look into what are the problems, why people are not hearing aids. So according to a study, it said that perceived versus actual benefits, stigma, access to healthcare, maintenance, comfort, and value in terms of benefit versus price. Value in terms of benefit to price. These are the reasons why people are not using hearing aids. So what is perceived versus actual benefits? It's what you expect to get out of something as compared to what you get. As with the technology today, with all the hype around every new technology in the market today, what you expect it to be is not what you get, and it's the same with hearing aids. The stigma related with hearing aids, the stigma of being considered as dumb, the stigma, the feeling of standing out of your group. Everyone wants to be a part of the group, but when you're using a hearing aid, it sometimes gives you unwanted attention. Access to healthcare, maintenance, comfort, value in terms of benefit versus price. So is it giving me enough for the price that I'm paying? Was also one of the reasons that people did not want to use hearing aids. Now that we're talking about the benefit versus price, so let's talk about price. How expensive could these things be? Really expensive. They start somewhere from around $300 to a couple of $1,000, depending on the functionality and the kind of device that you're using, the kind of hearing problem that you might have. The price ranges from a couple of $100 to a couple of $1,000, which is expensive. And even after paying hundreds and thousands of dollars, you're not getting what you want. You're not getting the clarity. You're not always getting the clarity in sound. You're not getting the sound localization that you want out of it. So, for people who are deaf and hard of hearing, hearing aids are not the solution. They are just a part of solution. And yes, for the past 5 to 10 years, a lot of research has been put into, has been focused towards the problems that people who are hard of hearing and people who are deaf are facing. But we still don't have a solution. We still don't have the answer to our questions. And that's one of the reasons why I wanted to build what we have done here, why I wanted to address this issue, because it makes a difference. 37.5 million, it might make a difference to 37.5 million American adults out there. Anyway, so let's move on to our project description. Okay, let's talk about my mentor, Professor Gary Bem. He is amazing. I didn't have any points here because I don't know what to talk about this person who is so big. I have no words for him. Just a general overview. He is the director at Center on Access Technology. He has 30 plus years of professional experience. He's worked with IBM. He's working with RIT, and he's recently started with a new job in Seattle. He has 15 patents. I think one of them is functional, and the rest of them are design patents. That is huge. The amount of support that I've got from Gary is phenomenal. He's been supporting me from day one. The day that I went in and told him, like, this is the problem that I've noticed around me, and this is what I want to do, this is what I want to work on. His support has been full on. He has never backed out. He never had his doubts. He's always been there for me through the problems that we faced, through my success. He's always motivated me. He always wanted me to. He's been so proud of me. He's always showed me to everyone that visits our lab that, look, this is the guy working with me. This is Rishikesh, and introduced me to everyone. And he's told them how proud he is of me. So I don't have a lot of words for Gary. He is an amazing person. Let's move on to the next slide with our objectives. So what we wanted to do through our project, what was the aim, what was the objective, what we wanted to get out of it when we started the project. Firstly, what we wanted to do is we wanted to reassess the problems faced by people in their day-to-day life, faced by deaf people in their day-to-day life. We wanted to understand them and hear it ourselves, and verify those problems that we've read through research papers. We also wanted to see, is there a demand for such a device? Is what we're trying to do, is that a solution to that problem? We wanted to see, do people really need help? Do they want Cherry? Do they want a device? Do they want an assisted device that would help them localize sound? Is that a real problem for them? Or have they found a workaround that problem and they don't need a solution anymore? We also wanted to design and develop an assistive wearable device. So if the problem exists, we wanted to design and develop our own prototype for this assistive wearable device, which would aid people in localizing sound. We wanted our solution to be lightweight. We wanted it to be cost effective, because one of the problems that we've seen with hearing aids is that they're expensive. So we wanted our solution to be a cost effective solution. We wanted it to be inexpensive, and we wanted to prove that we could use the existing technology that's been around us to solve problems that people face in their day-to-day lives. We wanted to show that you don't need to reinvent the wheel. You could just use whatever is around you and find a solution. So that was our objective for the Capstone project. We wanted to reassess, we wanted to confirm that this is a problem. We wanted to reassess that there is a demand for such a device, and we wanted to try and build our own device out of existing technology that's around us, and try to find a solution to this problem. Let's move to the next slide. So this is the timeline. This is the timeline for our project. We started research, we started identifying the hardware. So at first what we did was we started with research. We started with trying to understand the current solutions, research on those solutions and what problems that those solutions have, why we don't have the best solution for this kind of a problem. And while doing that, we also started identifying the hardware that we might need for this project. We ordered the hardware. We started during the phase between ordering the hardware and getting the hardware. We had about 2 to 3 months, especially due to the delay that we had while getting our hardware components delivered to us. We did possible sketches and circuit diagrams so that we don't waste space. Along with this, we also kept researching more and more and trying to find out the recent publications. We tried to find out the recent papers that have been published on this topic, so that we could identify the problem, so that we know what problems are we dealing with, what are the problems that we might need to solve. Then we started working on a code, a lot of working on our code. After we were done with the initial testing, after we got the hardware and we started the initial testing of the component, and we did the initial hardware, we assembled the hardware on the circuit, and we started testing a circuit and trying to test the compatibility of different components with each other. We came up with a simple algorithm that monitored the surrounding sounds using set of 4 microphones in real time, and the data received through these microphones was monitored, and if it breaks the threshold, we would call a function and pass the data that's passing the threshold to that new function, which would run the algorithm and give us the direction. As soon as we were at the phase where we were trying to get something out of it, we started conducting surveys and interviews. During this time, we also started participating in different competitions and conferences, so that we can show the world, show people who are interested in this kind of thing, this kind of technology, that this is what we're working on, so that we can get feedback from the people and interact with them and try to see what they think of our solution. So along with this, we did our surveys, and We did informal interviews. We went for effective access technology. We went for Buffalo conference. We went for the student research fair, NTID student research fair. So we did all this during the time till we got a final product. Till we got something, not the final product. What we had is something that identified a sound as a sound event. What we did was we used statistical methods on our data that we had. These methods helped us analyze the data and verify sound events. So when our algorithm verified that this is a sound event, we use statistical methods to confirm to the data that yes, this is a sound event, this could be considered, so that we know where we are a hit and a miss. We started separating sound events from sound environment, and we implemented haptic feedback by using these small vibrating sensors that you have in your cell phones. The problem that we faced, that people had with vibrating sensors, was that it was a little bit too strong for some people. So what we thought was we could connect a Bluetooth component to our device and have it communicate with a cell phone and have an interface over there which would help you adjust the intensity of the vibrations. So along the line we came up with problems, we solved them. Initially we thought that we would have haptic as well as visual feedback as a way of interacting with our users in order to let them know where the sound was coming from. We did build a visual, but it was a TFT screen that you could hold for the prototype. We did do TDOA analysis and TDO visualization on the screen to understand where the sound was coming from. We introduced new hardware along the line because the data that we're getting was not uniform. The sample rate was not uniform throughout the process. The sample rate we were getting was varying every second. So what we had to do was we had to get something that would make this sample rate uniform. So we came across an audio shield, and with some research we found out that yes, this could be used in order to get a uniform sample rate and process the sounds that we're getting. That didn't really work out for us due to power issues. The new hardware, the new audio shield, required a separate power supply, and for some reason we weren't able to do that. Whenever we tried it, our device stopped working. So we just scraped that idea of having an audio shield, and we tried to make our data uniform by forcing through code. So along the line we put in some LCD, we put visualizations, we worked on different versions of code. We have 27 versions of code, or every code has something different in it which makes a difference, which we thought might make a difference. And at the end of it we did testing. The testing was conducted at my friend's apartment, where we tried to create a soundproof environment. And what we did was we used a sound clip and turned it on starting from left, and we went 45 degrees every time anti-clockwise, and we recorded the results. What we got there was the accuracy was not good for our device. We think that it might be because of the ununiform sampling rate, but our accuracy was somewhere in the range of 70 to 75%, which is not good for an assistive wearable device. So that's it. So we did the conclusion and documentation. Let's move to the next slide. So what were the actions taken? We, at the end of the product, at the end of the capstone, we designed and developed a wearable device which would aid people with sound localization. It didn't really work out in our favor due to the lack of accuracy, but we were able to build something out of existing technology, which was, like I said, not the solution, which was a part of the solution. Maybe more work on this thing would help. We conducted surveys to assess the current technology available for people who are deaf and hard of hearing, and we reassessed the demand for an assistive device for sound localization. We also conducted informal interviews to understand the problem faced by people who are DHH and how they come across these problems. The reason we went with informal interviews was that in a controlled environment, or if the interviewee already knew what the reason for the study was, there was a chance that it might affect their views and their feedback. What we wanted was an honest view. What we did was around college, on campus, off campus, if I'm going out anywhere, if I'm going to the amusement park, if I'm going to a park, if I'm going to a festival, what we did was we identified people who are deaf or hard of hearing, or people who are along with people who are hard of hearing, and we went ahead, introduced ourselves, and we asked them for 5 minutes of their time or 10 minutes of their time, and we told them that what we want to do is we want to talk with you and understand, and we wanted to know how you deal with the problems, or what problems you face in your day-to-day life, and how do you deal with those problems, so that we get an honest feedback, we get an honest view of a person who is deaf or hard of hearing, or people around them, and hence the informal interviews. We also participated in conferences and competitions to get more input, feedback, and get more exposure. What we wanted to do is we wanted to show people that this is what we're working towards. We wanted the feedback from researchers, from professionals, from people out there who are visiting these conferences. We wanted to get their input, and we wanted to show them the work that we have done towards solving this problem, and hence the participation in various conferences and competitions. So let's move to the next. So what are the results? Like I said, we got about an accuracy of 75 to 80%. The direction, when I say in locating, we did not point towards the object an accurate degree. What our aim was to give you a general direction, so that when you point towards that general direction, your field of vision would help you locate that object or the source of sound that you're looking for. So we had an acceptable error rate of 20 to 25 degrees. So 20 to 25 degrees left or 20 to 25 degrees right. We did have a lot of a significant amount of false positives. So even if you're using the device and if there's no sound, that should be noticed by you, that doesn't stand out. our device did give us false positive, and that's one of the reasons that we think that we think that we are still not done. We're still looking for a project, for an answer. We still need to work on this device in order to find the answer, or work towards another device, or work towards some other solution that is a solution to the problem that people who are deaf and hard of hearing are facing. Through our surveys, we did reassess the problems faced by people who are deaf and hard of hearing in terms of sound localization. So we were able to verify the problems that we've seen in other research papers. We were able to verify through our surveys and through our interviews. We did establish a demand of assistive wearable device which would aid people with sound localization. So through the surveys, through the informal interviews, through the participation in all these conferences, through interaction with people, we were able to establish that there is a demand. People are looking for a solution. People want a solution for this problem. They do recognize this as a problem. So let's take a look at the survey results that we got. So let's talk about, so we surveyed a total of 23 people, and these are results that we got out from the surveys. So for people, we had all the 23 people using hearing aids, cochlear implants, and the satisfaction rate for people who were using hearing aids was kind of okay. Like 9 out of 23 people were satisfied with their hearing aids, whereas 6 out of 23 people were not satisfied, and 8% people said they were neutral towards, they neither agreed or disagreed towards being satisfied. So let's go towards problem locating sound. So we asked them, do you think that it is a problem for people who are deaf and hard of hearing locating sound? 18 people strongly agreed, 3 people agreed, and 2 of them didn't feel anything towards this problem. So basically 21 out of 23 people said that they identify sound localization as a problem in their day-to-day lives. We asked them, are you aware of the devices that help you locate sound? So people in general are aware. 15 out of 23 people were aware that there are devices that help locate sound, and 8 out of 23 said that they are not aware of devices that locate sound. We asked them, are you actively looking for a solution? I thought that this number would be huge, considering the first bar graph, which says that they identify this as a problem, but only 3 people said that they are actively looking for a solution. Probably because there hasn't been any new solution that's worth taking a look into, or maybe there's some other reason, but only 3 out of 23 people said that they are actively looking for a solution, and 11 people said that they are not looking for a solution at all. 9 people said that they do not feel, they're not as active, so they're not neither active nor do they disagree with this, with actively looking for a solution. And the 5th question was, if available, would you use a device for sound localization? So if there is a device that's worth looking into, and if it does solve your problems, would you buy it? Would you use it? 22 out of 23 people said that yes, they would like to know more about the device, and they would like to see a device that actually works, and they would like to use it. one person said it doesn't matter to him. Let's take a look at the results that we got from sound localization. So when you see 2, 4, 6, 8, so 1, 2, 3, 4, 5, 6, 7, 8, we've got 8 tests starting from right to right back, which is between right and the back. For every 45 degrees we did 10 sounds. So test 1, test 2, test 3, test 4, test 5, test 6, test 7, test 8, test 9. We played the same sound 10 times from one direction, and these are the results that we got. So sometimes, even though the sound was coming from right, so if we follow the right, if we follow the bottommost bar starting from 1, follow that sometimes it goes to right back for no apparent reason, and then it sometimes jumped to some other direction. So you can see that we did have some errors while doing the study, and we have reported. This is the final test that we did. We played a short sound clip for 10 times from one direction and recorded the results that we got, and we just plotted it, which gave us the accuracy of the device to 75 to 80%, more like 75, close to around 75%. It also we did not by this time we had put up strong threshold so that we didn't have any false positives, but it did not react to lower sounds with lower volume. Moving on to, let's talk about what's next. So the questions we were asked was, what would you like to see happen next? Basically a boost in technologies that end day-to-day struggles that people with disabilities come across. Not just for people with disabilities. I'd like to see this happen with any part of the community. We have we have a lot of technological advancements going on around us. I would like to see people taking advantage of the situation of the advancements in technology and try to come up with solutions for the problems that they've been facing. How could this come about? So basically, so more research into exploring problems faced by different communities. When I say research, you need to understand if there is a need, if there is a problem, there is a real world problem. You need to understand how they come across the problem in their day-to-day lives, so that you can find a solution which works better than what they already have. So more research into exploring the problems. What are my plans after receiving my MS degree? I've been offered a job at a company local to Rochester. I'll probably be accepting the job offer. I'd like to do PhD, and it would be kind of continuing what I'm doing right now. And I'd like to continue with my work on Cherry. I've already talked with my mentor Gary. He's agreed to help me out on this, and he's agreed to share give some of his valuable space from his lab so that I can continue working on my project. So Saturdays, Sundays, or whenever I get time, I'll be visiting the lab and I'll be working towards making Cherry better. We've identified some of the problems, and we've also identified some of the solutions to those problems. So we're going to try to end up with a device that will work 100%. Lessons learned. So what went accordingly to plan and what did not? Everything went according to my general plan. The milestones that I had, we did achieve all those milestones around the time that we were supposed to meet those milestones. So in general, yes, everything went according to plan. What did not was the details. When I thought like these are the details that go into developing this component or getting something to work. We had some issues with getting delivery for our projects. We had some issues with the components where they stopped working, and these kind of general problems that you have with electronics. So these are the things that did not go with plan, the minor details, but in general everything went according to plan. Also, we wanted to conduct a usability testing. Due to time constraints, we weren't able to conduct a usability test. We just conducted a test in a control environment, and we had to use that as our test results. What would you do differently? So I don't know, maybe have more backup plans, so that if some things that I assume that would go along in a certain way don't work around that way, or in case of ordering components, I'd order backup components. I'd have a backup plan for everything, because you never know what might go wrong, and you don't want to waste your time thinking of a solution when something doesn't go your way. I would have attended more conferences. I've realized that talking with people out there helps you get clarity in your thoughts. Conduct more interviews and surveys. We weren't able to conduct a good amount of interviews and surveys. I would have liked to do at least 50 interviews and about 100 surveys, but we didn't get that many surveys done. What is your advice to future Capstone students? That's a good question. So, in the past 3 years at RIT, I've realized, especially in the past 1 year, I've realized that RIT has the answers to all your problems. If you have any problem, whether it be your personal life, whether it's your professional life, whether it be a part of your student life, whether it's your course, whether it's your project, whether it's you need advice on something, RIT has people that are going to help you. You just need to look out for them. Start with your advisor. They know where to get help. When you tell them, whenever I had any issues, and Michelle knows I had a lot of problems. Professor Peter knows I had so many problems along the line, just completing my degree. They always showed me the right direction. If they didn't know, so if I needed help, I was pointed towards the right direction, and that really helped me out. So thanks to my parents, it's because of them that I'm here today. All the money, all the efforts, everything to getting me till here, it's my parents. Professor Gary, best mentor that I could hope for, and I hope you know how important you are to me. So Professor Peter, like I said, MS wouldn't have been possible without your help. Same with Michelle, solved every problem that I had. Professor Daniel Ashbrook, he was the motivator for me to get into electronics, hardware, and he was the person responsible for that I got into this kind of project, that motivated me to solve problems and to solve this problem. Professor Stanislaw, he let me use his lab, use all of the equipment that he had. He had advice. He was always supportive. He was there for some of my conferences, competitions, and good guy. Miss Sabrina Farah, she's a statistician from URMC. She helped me with understanding the data. She told me what methods that I might need to use and what resources I need to explore in order to understand the data. Whenever I had any issues related to data analysis, she was always there to guide me through it. FMS staff, how do I say, they were my lifeline. They were there to listen to all my problems. They helped me solve my problems. Through my employment at FMS, I was able to support myself with food and money. A big thanks to FMS. These are the resources and the references to the Capstone, to my presentation. If you would like to go through it, please do. Thank you. This is the end of my presentation. If you have any questions, please get in contact with me. Please try to contact me through my RIT email ID. It is hhk9433 @g.rit.edu. Thank you. Thank you for being here.